Alright, what we're going to talk about today is applications of proportions. Basically, when you have a word problem where there is a certain ratio given, typically you can solve by setting up a proportion. Okay, number one here, in a road atlas, the scale for a map of Connecticut is 5 inches equals 41 miles. So right there you have 5 inches to 41 miles. What is the distance in miles? So you're looking for X miles represented by 3.5 inches on the map. Okay, there are your two ratios. You set up a proportion. 5 inches is to 41 miles. 3.5 inches is to X miles. Now what you want to make sure is you keep the units the same. Inches went on top, miles went on the bottom, inches on the top, miles on the bottom, and that works like that. All we do now is cross multiply solve. 5 times x equals 41 times 3.5. That is 143.5. And you divide by 5 to solve. X equals 28.7 miles. Now, you really want to make sure that when you are doing word problems that you label your answers. Okay, just don't leave that 28.7. Make sure you write 28.7 miles. All right, example number 2. A crate is 1.5 feet high and casts a 2-foot shadow. At the same time, an apple tree casts an 18-foot shadow. So here's your tree, right over here. Here's the shadow. Okay, and here's your tree. So we're looking for the height of the tree. At the same time, let's draw a box cast a 2-foot shadow. Right there, those are going to be in proportion because basically you can set up right triangles and all right triangles are similar. The sun would give you the same angle right there, and then because you have a right angle, the third angle also equals, so therefore you have similar right triangles. When right triangles are similar, you can set them up in proportion. So you know that this apple tree has an 18-foot shadow. The crate, which is 1.5 feet high, has a 2-foot shadow. Okay, so you can set it up. The height of the apple tree is what you need to find. So you could do height over shadow equals height over shadow, or you could do height over height equals height over height. Doesn't matter, but again, you just want to keep them the same. So you could do height over the height. So height of the apple tree over height of the box, the crate, equals height of the shadow of the apple tree over height of the shadow of the box, okay, or length of the shadow. All right, so basically we did, this was apple tree and this was the crate. Okay, so the height of the apple tree, the length of the apple tree shadow, height of the crate, length of the crate shadow. And then you cross multiply. 2x equals 18 times 1.5. That is 27 equals 2x, so divide by 2 to solve. X equals 13.5 feet. That's how tall the apple tree was. Okay, and that's something called indirect measurement, how you measure without actually measuring the top of the tree. All right, let's turn this over and look at the next example is about converting units. Now, if you watch the Olympics, you know this guy, Usain Bolt. He holds the world record in the 100-meter dash with a time of 9.76 seconds. How many miles per hour is that? So basically, you have 9.76 seconds in 100 meters. Now, in order to do this, what we have to do is convert units. We want to get, in the end, we want it to be miles per hour. Right now, we have meters and seconds. So because we have miles on the top, we're going to put 100 meter over 9.76 seconds. Okay, and then you can work with either one first. Now, first of all, let's look at this. We know that 1.6 kilometers equals 1 mile. We also have meters, so we need to change from meters to kilometers. Well, I can tell you this, 1 kilometer equals 1,000 meters. So what we can do here is say there's 1 kilometer in 1,000 meters. not equals, I'm sorry, we're going to multiply there. All right, so you're going to multiply. What happens here is your meters cancel. Okay, so now we're at kilometers per second. Now we have to change kilometers to miles, so we know there's 1 mile in 1.6 kilometers. Now our kilometers cancel. Now we end up with miles on the top. However, we have seconds, so we have to change that to hours. Well, go 60 seconds in 1 minute, and then 60 minutes in 1 hour. So your minutes cancel, your seconds cancel, you will be left with miles per hour. Okay, so it's all about multiplying to cancel your units and getting this part the correct, 60 minutes in 1 hour. So you want that piece correct with your numbers, but it's about canceling your units. Okay, and now we can just multiply. See, on the top we have 100 times 1 times 1 times 60 times 60, and on the bottom 9.76 times 1,000 times 1.6 times 1 times 1. All right, you can reduce, you can do that, however you choose to do that. In the end, you should come out with, let's see, we can cancel 100 with 2 of these, so you get and then let's say 10 goes into 66 times, so that's 360 on the top. On the bottom, when you multiply 9.76 times 1.6, get 15.616. Divide that out, 23.05 miles per hour. It's pretty fast. He is pretty fast. If you watched him in the Olympics, he was fast. All right. So there's a couple examples on setting up proportions and solving, one example on converting units. So here's a couple you try. Okay, they're both actually proportion. We'll do some more of the units in the next class. All right, so have fun with those, and we'll see you next class.